This is our handy reference for all the quarks in particle physics, right? They're going to ask about the charge, right? They're going to ask about strangeness number. They're going to ask about baryon number. Okay. Remember that the baryons are quark, 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 right? So they're going to have a baryon of 1/3 plus 1/3 plus 1/3, right? Whoops. And that of course, antibaryons, like an anti-neutron, right, is going to be quark, 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 right? You have to remember that a proton is up, up, down, right? And that a neutron is up, down, down, right? You should be able to, with this thing, calculate the strangeness and all that stuff and the charge given quark compositions, right? And then the lepton, this has to do with the lepton number, right? Remember that these guys, this is small mass, right? This is small and stable. And that leptons are conserved, right? The lepton number is conserved, right? And then that a muon is just a fat electron, a tau is just a fat muon, right? These guys all decay to that. And all these decays, like a tau decay always carries off the tau number as a tau neutrino, okay? And you can look at the review things there, right? And then this is just the generations of fundamental particles, right? And so electromagnetic force charged particles experience it, and that the photon, that's a photon. The photon mediates it, right? The strong force is mediated by gluons, and quarks and gluons experience a strong force. The weak force is quarks and leptons experience that, and these are the things that mediate the weak force. And then, of course, everything, gravity is the one force that binds them all, right? Okay. All particles experience gravitational force, and the as to be yet discovered graviton will be the thing that mediates that, right? Okay. And then we've got, if you look at this, we've got fermions, right? And fermions are non-integer spin. All right, so this is spin 1/2, right? Okay. So as you look at baryons, right? Baryons have 3 quarks, and all of the quarks have 1/2 spin, right? And so the baryons are going to be strongly interacting fermions, right? They'll interact with a strong force because they're made of quarks. Anything with a non-integer spin obeys Fermi-Dirac physics, which is like the Pauli exclusion principle in that, right? And then bosons have integer spin. Okay, these things all have integer spin. It could be 0, right? So the Higgs boson is 0, right? But it's going to add up to 1. So mesons are going to have integer spin, right? Because they're made up of 2 quarks, right? And so they would have integer spin as well. Okay, they would be strongly interacting bosons. Okay, yeah. Anyway, that's the particles. Sort of an overview of that. Take a look at the videos that are below this and work through those. Those seem to be the questions that are on the IB tests. So anyway.